So we have 4 vectors we have to take care of here. So I'm going to start with our first vector. Okay, this will be v sub 1. West of north means it needs to be touching which axis? It needs to touch the north axis. When I'm drawing these vectors, when I start out with west of north, I know it needs to go this direction somewhere. So I can start by drawing that kind of arbitrary vector in the north and the west direction, and then I can decide, okay, I know it needs to touch the north axes, so I'll build that triangle from there, and I'll know that my angle sits right here. Okay, so there's 54 degrees, and it's at 36 meters per second. Does it matter to us that these are velocity vectors rather than displacement vectors or force vectors or acceleration vectors? No. It doesn't make a difference in how we do the math to find these. Okay? So I would label this v sub 1 x and v sub 1 y. So if as I'm working through this you are getting something different or you're not seeing where these numbers are coming from, please stop me and ask, okay? Because we have to understand where these numbers are coming from. Okay? Why is my x component here negative? Oh, yeah, yep. That doesn't really make sense. Sorry. I plugged something in wrong. There we go. But it should be negative 29, right? Negative 29.1. And why is our x component negative? Because it's going west, right? And the math does not tell you that. So after you solve for a component, you have to check, is it going west, is it going south, and add that negative, okay? Okay, east of south means I need to draw my vector somewhere in the southeast direction. What axes does the angle need to touch? It needs to touch the south axes. Okay, so my angle is going to fit right here, 82 degrees, and my hypotenuse is 56 meters per second. Excuse me. Okay, this vector is only going east, so that means v sub 3x is positive 15 because it's going east, and v sub 3y is equal to 0. Okay. We don't have to break anything down on a vector that's going either pure horizontal or pure vertical. Our last vector is heading south of west. So I'm going to draw my vectors in the southwest direction somewhere. I know it needs to touch the x or the west axes. So 62 degrees goes there, and 92 meters per second is our hypotenuse. But here we're going to solve v sub 4x and v sub 4y. And should our x component be positive or negative? Negative, right? It's going west. And our y component should also be negative. Okay? So is it a rule that we always use sine for x and cosine for y? No, it is not. You have to pay attention to the triangle itself. So for this last triangle, our x component, v sub 4x, happens to sit adjacent to the angle we have, which means we need to use cosine. Okay, our y component happens to sit opposite of the angle that we were given, which means we need to use sine. So do not make it a rule that x always gets sine and y always gets cosine or vice versa, because that's not true. You have to pay attention to the angle that's given. Okay, and to the triangle that's given. So do not start to make assumptions that x is always sine or cosine or whatever. Okay, you have to follow that true triangle. All right, so do we agree with our components? Yes or no? All right, so what's our next step? Add all the x's and add all the y's. Okay, so let's go ahead and do that. And I'm just going to call this v sub x for our resultant vector. We're going to add all of our x's, so negative 29.1 plus 55.5 plus 15 minus 43.2. Before you start with this step right here, I don't think it's a bad idea for you to double check each of these vectors to make sure you have your negatives right. Okay? Go back and think, okay, my x component here should be negative, my y is going north, so it should be positive. My x component's positive, my y component should be negative. Both should be negative in our last one. Okay? You can tell just from looking at your cardinal directions, right? Here, our west component should be negative, north should be positive. X should be positive, y should be negative. We can tell by just looking at those cardinal directions. Okay? What do we get for our component for the x direction, our x component? Negative what? Negative 1.8. $67.9. Okay, so that means our x component needs to go which direction when we start to draw our resultant triangle? It needs to go left or to the west, right? So now we've got our y component and our x component of our new resultant vector. Which one is a negative? I'm sorry, you're right. This is negative 67. So it needs to go south. Okay? So now when we draw a resultant vector, we're going to start with our origin. And we can draw south first, then west, or you can draw west first, then south. It will not make a difference. Okay? I'm going to go west first, and then my south vector should be much, much, much larger than my west vector. Okay, and these aren't exactly drawn to scale, but they should be, at least close. Okay, my x is 1.8, and my y is 67.9. When we're drawing these vectors in our resultant, do we need to include the negatives? No, the negative tells us a direction, so we don't have to include the negative in that particular part of it when we're drawing our vectors. Okay, so now our resultant, we want to find the hypotenuse and the angle of that triangle. Okay, so from there it's just simple Pythagorean theorem. Okay, so our resultant is not much larger than one of our components, right? And that makes sense because we've got a really small x component here. So go ahead and include that next decimal place. Don't round to make it equal to. Go ahead and include one more decimal place so we can see that it's a little bit larger than our component. Okay. How do we go about finding this angle right here? Second tangent. Good, second tangent. So I'm going to say take second tangent of opposite over adjacent. So second tangent of 67.9 divided by 1.8. And I get 88.5 degrees. Blank of blank. What is it? South of west. Good. Okay, we know it's south of west because our angle is touching our west axis, and then we decide from there, is it going north of west or south of west, and we know it's going south of west. So this one only has two vectors you're concerned with. It's a lot simpler than the one we just did. Okay, same process, just a little shorter. All right, so let's move on to some friction now. So is this object on an incline or is it being pulled at an angle? No, it's not on an incline. Okay? This says it's being pulled on a horizontal sidewalk with a rope that makes an angle. Okay, so what happens here is that we're dragging our object. Okay, I'm pulling on it with some rope at 45 degrees. It's not on an incline. Okay, so this is two different types of problems. This is being pulled at an angle. Okay, so our free body diagram is not on an incline here. Our free body diagram should look something like this. Force due to gravity, or normal force. Do we have friction here? Yes, and how do we know that we have a frictional force? Yeah, it asks us for the coefficient of friction, which means we must have a coefficient of friction, which means we must have a frictional force. Okay, and our applied force in this case, is it being applied horizontally or being applied at an angle? Yeah, it's being applied at an angle. Okay, so now we've got a force that's applied 150 newtons, but it's applied at a 45-degree angle. Okay, which means we need to break it down into F applied X and F applied Y. Okay, so just tell me right off the bat here, is our normal force and our gravitational force going to be equal to each other? Will our normal force and our gravitational force be equal to each other? No. No. How many vertical forces do you have? 2? You have 3 vertical forces. 1, 2, 3. That means the normal force and the gravitational force cannot be equal to each other. Okay, I have to have you guys seeing that. Okay, we have to calculate the normal force by using those three forces up there. Okay, if we only have two, if it's only the normal force and the gravitational force, then yes, they would be equal to each other. But here we've got this y component of our pulling force. It's taking some of that pressure off the normal force, which means they are not equal to each other. Okay, we have to be able to see that. Okay, so first thing we need to do is break down this applied force into its components. So we need to find F applied x and F applied y. Shouldn't both of our forces, or both of our components, be equal to each other? Yes, because it's applied at a 45-degree angle. Okay, those components should be equal to each other. So, now that we've broken down this 150, we are completely done with it. It does not go into our problem ever again. Okay, once we break down that applied force into its vertical and horizontal components, we don't use it anymore. Okay, so if you feel better drawing this applied force on top of that vertical force so you can see it there, that's fine. You can get rid of it. You can move this force over on top so you can see it's a vertical force. If not, you just have to be able to recognize that it is a vertical force. So it is taking, and you have to take it into consideration when looking vertically. Okay? So our coefficient of friction, is it going to be a vertical or a horizontal force? Which should we be concerned with when we're looking at coefficient of friction? Horizontal, right? So I need to set up my net force equation in the horizontal direction. There's multiple paths you can take to get to your final answer here. If you want to solve for the normal force now, you could. You want to solve for x first, you can. There's lots of different ways you can get to this final answer. So you don't necessarily have to go in the order that I'm going in. Okay? F net in the x direction, we're going to take rightward forces minus leftward. So what's our rightward force here? Yeah, 106.1, or F applied x, minus our force of friction, which we don't know yet. Okay? What does this tell us right here? Constant speed. Yeah, our net force in the x direction is 0. Okay, that means our frictional force is equal to 106.1. Okay, but it doesn't ask us for our frictional force. It asks us for the coefficient of friction. So what's our equation for the coefficient of friction, or the frictional force, I'm sorry. What's the equation for finding the frictional force? Good, coefficient times the normal force. Okay, and we don't know either of those things yet. We're solving for the coefficient, so we want to leave that there. But we can find the normal force. So now let's start looking at our vertical forces here, since the normal force is a vertical force. And how many vertical forces do we have acting? We have 3. Okay, we talked about that earlier. 2 of them are upward. So normal force plus F applied y. And 1 of them is downward. F of g. Okay, or force due to gravity. Is our box, is our crate accelerating in the vertical direction at all? No, we're not lifting it off. It's not moving in the vertical direction. So our net force in the vertical direction is also 0. You're solving for your normal force. You know your F applied y. And what do we know about F sub g? Is it 400 or is it 400 times 9.8? It's just 400. Okay, that equals F sub G because it's already given to us in newtons. Okay, do not take that 400 times 9.8. Okay, so were our normal force and our gravitational force equal to each other? No. Okay, we need to be able to see that when there's more than two vertical forces acting, those two will not be equal to each other. So now I'm going to take my normal force and I'm going to plug it into my frictional equation. 293.9. And I'll take 106.1 divided by that 293.9. And I get a coefficient equal to 0.361. If you feel like you can do this problem on your own, please do so. Okay? You don't have to wait. Okay? But if you're stuck, I will work it up on the board, but I want you to try to get through these on your own if you can. Okay? So tell me before we get started, what's our overall goal in this problem? What's our overall goal going to be to find? Time. Very good. Time. Okay, so you will need your kinematics equation for this eventually. So you might want to get those out if you don't have them out already. Okay? That's going to be our overall goal here eventually.